medieval on that one. It's so fun I'm wearing. Just too tight on my boots.
Damn. There's 2.5 inches of nail in it.
I got the winner. Oh. Do you have the voice on?
Yeah, it's recording audio, but we can cut it out.
Okay. Somebody got a little medieval on the bolt torque here.
Yeah.
And one more bolt left. Interesting. Bolt's supposed to be metric. Sure I didn't forget any. Yep, there's one more up there. I forgot. One bell housing. We'll check the bell housing alignment after we get the clutch off. What we're going to do is check the clutch, see what kind of condition the clutch is in. We already know the rear main seal is leaking like a sieve, so we're going to put a new rear main seal in it. And we know that the pilot bushing is probably worn out from my initial inspection. The pilot bushing is bad. It doesn't support the front of the transmission's input shaft, and you'll tear the front bearing up in your transmission. is the original Sachs 13-inch clutch. That pressure plate cover there is made out of solid iron, and it's not light. So when you take out that last bolt, it's a good idea to be ready for it. Friction material was made by a company called Raybestos. It is not asbestos. It's a non-asbestos formula. The clutch plates were normally smooth. There was no waffle grooves in them like most clutches have. So just because the clutch plate's smooth when you take it out does not mean it's worn out. In fact, these clutches have been known to go. I've seen them with more than 300,000 miles on them and still be within specification. All right, for our next trick. Pause. What are you doing, you dopey dog? Oh, Ben is here. Okay, you can pause it for a minute.
Good.
All right, this is your typical 89 through 93 Dodge Cummins flywheel. It was originally designed with this lip on it for the Sachs 13-inch pressure plate. This lip is what goes all across this edge right here. That's what centers this clutch. If you do not have a flywheel with this lip on it, you really shouldn't use this clutch. Likewise, there's two different styles of this flywheel. The very early flywheels did not have this groove in them. They were kind of sloped down, so if your transmission leaked any oil, the oil would come here and it would fly right under your clutch facing and make the clutch chatter like crazy. Gotta love that. So what was done, which later, was this groove was cut in here. So if any of the oil comes in, it'll come into this area here, and then it will, as the rotation goes, there's a hole drilled, and it will sling the oil out the backside of the flywheel, so you don't foul your clutch disc. The pilot bushing here is made out of a cindered bronze. If the bell housing alignment is not correct, either the alignment this way or the alignment this way, it'll put a cock on the input shaft. The end of your input shaft will look like it's like barrel shaped. That's your dead giveaway. Your bell housing's not lined up. Also, when you check that, see how much that input shaft wiggles in there? If it wiggles that much in there, what that'll do is it'll tear up the front bearing of your transmission. You should never rebuild a transmission and not check that pilot bushing to make sure it's tight. You really shouldn't have any more than just a little like that much right there maybe. But this is ridiculous. I usually make that bushing out of a standard phosphorus bearing bronze on the lathe, which is different than the bronze that the original was made out of. The original is just powdered metal, and they put it in like a mold and then heat it electrically, and it's impregnated with oil. It's a great theory, but powdered metal is kind of spongy, so it compresses easily. Remember, when you're going down the road in overdrive, the power comes in here, goes through this gear, down here through the cluster, and then back up and out again. So whenever you put torque on the engine, you're always forcing that gear upwards like that. So you have to have that bushing up front always being supported properly, and it's imperative that the bearing preload in the transmission is set properly so it has the right clearance. I've developed a new procedure for overhauling the transmissions for figuring out the bearing clearance. You'll see that in one of our future videos. Now let's get on with the project.
All right.
Ready?
You good?
All right, now we're going to do something. We're going to replace the rear main seal. This is not for the faint at heart. If you make a mistake on this, you'll ruin the crankshaft, and you'll have to disassemble the engine to have the crankshaft's rear main seal turned. Or you'll have to put a wear ring on it, one or the other. The bottom line is, don't screw up. I take an ice pick, and right about the center of the seal, I take and tap a hole in it. And it didn't work out like I planned. Okay, cut.
Okay, I'm good.
Now what we're going to do is replace the rear main seal. I've got a 1/8 drill bit. And I just drilled a hole in the seal. If you miss and nick the crankshaft, you're going to be very unhappy because you're going to have to put a wear sleeve on the crank, or you're going to have to take the crank out of the engine and have the seal surface reground. So you want to try not to do that. Then what I do is I take my handy dandy screw knocker here. Screw it tight into the hole, taking care not to jam it into the seals to the crank surface. Voila. One rear main seal. Notice how nicely it's leaking. These seals are never were much good. There was about a dozen revisions of the seal. The ones that have the rubber coating on the outside of the seal are the best ones of the bunch. Cut.
You good?
Okay, I'm going to take a rag, and I'm just going to take a rag and wipe around that just to get any of the soot and smoot off it. This is a clean rag, or was a clean rag. Don't go using one that you got laying on the floor with all that grit and grime and stuff in it. It's not a good plan. All this oil right here that you see is more than likely come out of the rear main seal. You can see the black there. Also, what happens, valve covers will leak, and the oil from the valve covers will run down over the bell housing and come into air vents at the top of the bell housing. the bottom line is we don't like oil on our clutches. That's not a good thing. Anyway, let's see if we can manage to put the rear main seal in. This tool right here that they give you with it's for knocking the seal in. I have mixed emotions about that tool. Don't knock this ring out and necessarily handle the seal with your fingers. They say that it screws the seal up. But what this is for is to line up the seal. So slide it down over the crankshaft. So let's see if it works. I'm putting that plastic thing over top of the crankshaft. And the theory is that the seal is supposed to push now down over top of that. All right, now that we've gotten it over there, now you pull that thing out. And the idea of this tool is to gauge how deep the seal goes into the bore. Just work it on around. Take a little break when you get tired. And there you have it. Make sure it's equal all the way around there. That inner edge will just touch up against the crankshaft. And when it touches up against the crankshaft and it's tapped all the way around, you're good. At least that's the theory. Okay. Now we're going to stand by for a second while we go scrub the parts. This is an exhaust hanger bushing. This part goes to the pipe. This part bolts to the bell housing. A lot of times these are missing. Most of the time the rubber is completely gone in them. We have the replacement rubber bushings for these. That bushing was never offered by Chrysler as a replacement part. You had to buy the whole thing. If you do not install this, if that rubber is not good, what will happen is your exhaust pipe will swing around and it will crack the flange off up on the turbocharger on the exhaust system. So this is a critical part and it must be returned to where it came from. Ready? Once again, this is the rear main seal that we removed out of it. You can see the grease and oil all over it. There's been several revisions on this seal. You know, the inner lip of this is just a piece of Teflon. It starts out flat and then it's squished out. There's no spring to speak of on it. The idea is the internal crankcase pressure is supposed to keep that seal tight against the crankshaft. Well, it's a great theory, but it doesn't work well in reality, apparently. So anyway, the latest and greatest seal revision has rubber around the outside of it. We're going to do some experimentation in the future. I'm going to try and find a seal that actually is a real like a nitro lip seal. We're going to see if those work and how long they'll work. When these engines are not under load, you're not creating a whole lot of crankcase back pressure. And without any crankcase back pressure, you're not going to really keep that seal out tight against the crankshaft. So more on this later. When we attack that project of solving the great rear main seal dilemma. All right, let me cut that front. That's it. Okay, tell me when you're ready.
Go ahead.
All right, here's our bell housing. This is the factory bell housing. These two areas right here that have the large holes, we used to call those dowel pins. I guess they still are. Here's one of the dowel pins that's supposed to be in the adapter plate on the engine. And then you press, that's supposed to be pressed in the engine, and then this goes in like that on either side. And the idea of that is so it lines the bell housing up with the center line of the crank. In other words, that hole right there has to be in line with the center line of the crankshaft. Obviously, we would like it to be zero, but it's never going to be because of manufacturing tolerances. The fact that these bell housings now are, anywhere from 15 to 18 years old, the bouncing and pounding of the truck going down the road and the transmission supported back here by a cross member, it'll cause the bell housing to actually warp. The transmission here will actually go like this. So this surface right here has to be exactly parallel with the back of the engine block. This hole right here has to be perfectly in line with the center line of the crankshaft. If they are not, it'll put a bind on your input shaft and your transmission, and it will destroy your transmission. The majority of these are warped. I always check this putting it back together, because if the transmission fails and you don't figure out why it failed, then it's going to fail again. Transmissions just don't burn up bearings for no reason. Generally, the transmissions run out of oil is what happens first. We've developed a dipstick tube, much like an automatic transmission would have. We'll go over the dipstick later on. In any event, now we're going to check the bell housing to make sure that it is centered with the crankshaft and parallel to the back of the engine block. Okay, you can cut it.
All right, you're good.
All right, what we have here is a barring tool. At least that's what they call them in the books. It slips inside the bell housing. It hits the flywheel. What we're going to do is rotate the engine, and we're going to check to see if the bell housing's in line with the block. I might also add that most all of your Chrysler manuals have bell housing alignment outlined all the way back into the 40s and 50s. So any of the Chrysler books will explain bell housing alignment for the old gas engines. The principle's the same. Anyway, as you can see, I drilled a hole in this. And I drilled a hole in it so I can stick it on this extension, and it locks in place and it doesn't come off. That extension, it's got a pin on that for a D10. Then I tap this out and I put a 1/4-inch set screw in it. Now I'm going to tighten it up. The reason why I do this is because when you're fishing that thing down inside the engine compartment, it's really annoying when that thing comes off or flies off, and you have to go hunting for it. Also, sometimes this jams a little bit in there, and when you want to take it out, you want to be able to just pull the whole thing out. So it's not essential that you do that, but I find it interesting. Most of these are 3/8 drive. You can get a 3/8 drive universal impact joint. You can get 3/8 on one end, 1/2 inch on the other. I recommend using a 1/2 inch extension because it doesn't flex as much when you're trying to crank the engine. No need to buy an expensive extension like that. As you can see, that extension is Oh, it's roughly, well, what, 3 feet long. And you can buy a cheap extension. It doesn't really matter. Just make it a 1/2 inch one. What we're going to do now is we're going to install this tool in the hole in the side of the engine block. Or should I say?
Hang on, I screwed up. Say that last part again.
So what we're going to do now is we're going to install our boring tool with ratchet into where it needs to go. Okay, cut for a second. Are you ready?
Okay.
In any event, when you install the boring tool, it's a little hard to see here, but it's outlined pretty clearly in your Dodge factory service manual. If you use that long extension, you can bring it up here just like this, and then you can have your buddy crank your engine around. Then when you're done, you can just pull it out and you don't have to worry about it coming apart and dropping all over the place. Anyway, now we're going to go up underneath the truck.
Go ahead.
Okay, what we've done here is we've installed a dial indicator. As you can see, the pointer is on the bore of the bell housing. Now, Brother John is going to rotate the engine, and you're going to watch that needle. And if God really loves us, that needle right there will stay where it is. Well, we're already got 5,000s. As you can see, the needle is moving. That means our bell housing is out of line. So what we're going to do is find the highest, we're going to find the lowest spot, readjust our dial indicator, and then when it comes around to the other side, we're going to know how much it's out. Okay, John. That's it.
All right. Go ahead.
All right, as you can see, the needle right there is on 25,000s. You can see that the plunger is right here. When the plunger was up here, I had it zeroed. When it was up here at the top, it was zeroed. So right now we know that we have 25,000s difference. So what it really means, you take half of 25, well, it's almost 26 thousandths. You divide it in half. So 13 and 13 is 26 thousandths. So technically, we know that this bell housing needs to move this direction 13 thousandths to be 0. 13 thousandths, I believe in the book, they tell you is good enough. In reality, 13 thousandths for alignment is kind of like saying, well, I'm driving in all 4 lanes at the same time. I like 2 or 3 thousandths. That may not be realistic, but with our new bell housing and with proper installation procedures, that's what we want to achieve. And not only do we want to achieve that 13, we want to achieve that couple of thousandths on center line, we want it to stay there indefinitely. The other thing you have to worry about on these, you have to take your dial caliper and you measure the bore here, because sometimes these bores go egg-shaped. They stretch and go egg-shaped. The next thing we're going to test is the face. In other words, is this parallel to the back of that engine block? Is this face 90 degrees to the crankshaft center line? So we're going to set up the dial indicator in that fashion. The dial indicator that we're using, if you look inside there, it's just a basic magnetic mount, and we just left one of the flywheel bolts off, so we had a flat surface to mount it on, and then we just adjusted around to the pointers touching the inside of the bore. Pretty basic stuff. Now we'll just manipulate that dial indicator around. I may use another indicator that I have just because it's easier to see for face shots. But we're going to run around the face of that. So we're going to set that up, and while we're setting that up, we're going to set the camera down.
Go ahead.
Now you see I've got my face dial indicator and the pointer's rubbing around here on this. You can do it with the other type of dial indicator, but the face will be facing the other way, and when you get up to the top up here, you can't see it, so you have to take a mirror and read it. Dial indicators are pretty inexpensive now. You can buy them out of China. We don't need a super duper one. You can probably buy one for $10 or $20 these days. Anyway, now we're going to turn over the engine and see what happens. Cut.
Okay.
What we did was we ran this around here a couple of times. We didn't bore you with that because you'll get the idea here. I finally found that the low spot was at the top. The high spot was at the bottom. So this bell housing, from the weight of the engine and transmission bouncing and pounding, with the motor mounts up front and the trans mount back here, just going like this. It'll cave it in at the top and it'll pull it out at the bottom. So what we're going to do now is we've got a dial indicator reading of about 7 thousandths. That's within specifications, but I really kind of like to have things nice. So what I'll do is I'll take some 7 thousandths shim stock. You can use beer can, tin can, siding, anything. Just measure it for what size, for the size you want, for the thickness you want, and then just put it underneath the bolt holes on the top of the transmission, and that'll usually straighten it out pretty good. Rather important. In any event, now we're going to remove the bell housing and we're going to torque down all of our flywheel bolts with a torque wrench. We torqued them down with a torque wrench because it's very, very ugly if your flywheel happens to fly off when you're going down the road. And diesel engines vibrate violently to begin with. So just to be sure, we're going to lightly lubricate the bolts and then we're going to torque them down to factory specifications. Cut.
Go ahead.
Notice the difference in bell housings here. This is our original bell housing. And this here is a bell housing. This is our original prototype. And we're going to have a cover that goes over top of the starter here. And it's made out of billet steel. And then this plate is then MIG welded on it. It's all laser set up and all that kind of thing. And we're hoping that this bell housing is not going to break. This bell housing would be customarily used behind a couple thousand horsepower dragster. So I feel that this is probably going to solve any and all problems. We're going to be doing a new transmission conversion for this. It's going to be a 5-speed spicer or a 6-speed spicer that we're going to be doing. And it's going to be able to work with this bell housing because we have the flat plate here. We can change that specification to anything we want. We can also change our depth to anything we want. So there's going to be some real truck transmissions with overdrive for this in the future. And I'm looking forward to getting this project underway. This is our prototype bell housing. So we still have a few refinements to make. That's it. All right, I'm going to muscle this bad boy in place. I'm using an old input shaft. You can use a piece of, if you got a lathe, you can use a piece of dowel turned to the right diameters on the lathe. Cut.
You got it.
All right, as you can see, we muscled the pressure plate and disc up here. We got our bolts started around here, finger tight. Now we're going to go around and run them down. we're going to run them around evenly. What we're going to check for is that on the side of the lip of the flywheel, that pressure plate's gone down inside that lip evenly all the way around. While you're doing this, you also want to check your input shaft here because it'll bind. What you want to do is while you're doing this, you'll take a mallet and just tap it this way or tap it that way until you can slide it in and out easily by hand, like that. As my socket rolls away. Yeah, a little bit of a crisscross pattern is good. Bear in mind, I've been using this impact wrench for 40 years. So I'm kind of familiar with how tight it's making these bolts. But even though, I'm still going to get my torque wrench afterwards, and I'm going to torque those bolts down to factory specifications. The factory specification is... Alright, we won't bore you with going around and torquing them down with the torque wrench. The next project is putting in the transmission.
Go ahead.
Again, you take your torque wrench, torque the bolts down, like I told you. Now we're going to put the transmission in, or the bell housing on. Now, if you tap that thing around right, you should be able to pull it out just as easy as pie and push it in. If not, you tap it back and forth with your mallet until it does. Because what you're doing is you're wiggling the pressure plate, or you're wiggling the disc around until it slides nice. Because remember, when you go to put that transmission up there, if that shaft doesn't go in and out of there easily, you're going to have to be tugging and pushing and all that kind of thing to get it going in there. And you really don't want to force things together like that. You can break things. You can break the pilot bushing and push the pilot bushing out. So you want to make sure that shaft comes in and out nice and smooth. Cut.
Go ahead.
All right, here's our bell housing. This truck is the bell housing. We're going to reuse it. Before you put the bell housing up there, oftentimes it's a lot easier just to go ahead and put the fork in now, because once you get it up in there, it's a little clumsy. So before you put the fork in there, you take a dab of grease and put a dab of grease down in the ball, and you look at your ball assembly down here and make sure it doesn't have any nasty flat spots worn on it, and likewise. So I'm going to put a little grease on here and slide it into place. You have to make sure it snaps down into place like that. Now I'm probably going to go get the throwout bearing. Throwout bearings come in two varieties. They come as one piece assembly just like that, or you can get just the bearing part itself. As long as there's no big ditches really badly worn in this area here, and as long as this bushing area here is not really badly worn, you might as well just get the bearing itself. This bearing is actually readily available most anywhere. It's actually an old bearing that was actually used in Chevrolet trucks, I believe, back in the 40s. Anyway, To get the bearing off of its shoulder, you stick it in there. I've got a nice tool here for doing this. You don't necessarily need this tool. If you have a lathe, go over and make you one, or you can take a piece of dowel, a piece of wooden dowel or a piece of PVC pipe for that matter, and cut it down to fit the inside diameter of this. And just knock it out. So we'll stick that up there like that. Then the adapter falls in your foot. Alright, there's our bearing assembly. And we're going to probably reuse this bearing just because there's really nothing wrong with it. And there's your hub assembly that it mounts on. We're going to go ahead and clean this bearing up and we'll be right back. All right, what I'm going to do here, so I'm just going to pop a little tiny pinhole in this thing. This is the outer shield of the bearing. Now a lot of you guys probably don't want to be bothered with this because these bearings are not expensive. And you may not want to run the risk of having to do the job again. But back in the old days, we didn't have tremendous amounts of money laying around, and sometimes we had to make do with what we had. I've got this little tool right here. I'll wipe all the dirt off it. And I put in my handy dandy grease gun needle. The majority of clutch failures start with a bad throwout bearing that's run out of grease. Open up my hole a little bit more. Now you wipe it off good. And I'll mix up a little bit of JB Weld. Just put a little plug over top of. a little top, you know, you have to edit that out. You can take a break, probably mix this up. All right, I'm just sanding that off a little bit, so it'll be a rough surface. And I'll just take a little dab of this JB quick weld. Takes about 5 minutes for it to set. Don't have to be real fancy smancy about it. Just smear it on there like that. And okay, that's done. Now we shall take the hub and press the hub back into the tool. Notice that the hard face goes away from the hub like this, and the hub goes in from the back to the tin can side. So all you do is just lay it down there, your surface, and stick your fancy tool back in it. Probably just lay a piece of wood across it and smack it too. Not a real high-tech thing. All right, now we're going to go back out and install this in the vehicle. We'll be right back. Tell me when.
Go ahead.
Inside this throwout bearing hub, there's a groove. And in that groove is grease. What you do is you clean all the nastiness out of there. Then you take a little bit of grease and you pack that thing full of grease, but you just put enough grease on there that it's flat all the way around. You don't want to have a lot of grease spewing out all over the place. Then you put a little bit right there. That's where your clutch pivot is. Waterproof grease works best for this. But if not, any good wheel bearing grease will suffice. And then generally what I do is I go ahead and snap the throwout bearing onto the clutch fork before I put it in the vehicle, because once this thing is up there, it's kind of annoying to get these little clips clipped. And then to make things kind of stay in place, I take our rubber boot, which, believe it or not, that rubber boot has been used since about 1962, all the way up to 93 on all the manual transmission Chrysler built vehicles, cars, trucks, you name it. Okay, now we're ready to put the bell housing on. Before you put your bell housing on, however, you make sure that all these surfaces are clean, that there's not a lot of rust and garbage and junk all over them, because that'll knock your bell housing alignment out also. All right, we're going to go back underneath the vehicle and we're going to put up our bell housing. Now remember what I told you about the dowel pins earlier. You have to make sure those dowel pins are seated in there. That's what centers this bell housing with the crankshaft. If those fall out or are missing or damaged, you'll end up in a world of trouble. All right, now I'm going to put the bell housing up here. Better put a couple bolts in there and get started so it doesn't fall down and hit me on the head. Universal impact sockets are kind of nice for doing this. Stick right up in there and get started. Okay, now that we've got that taken care of, I'm going to get my impact wrench and get my air hose. Okay, cut. There's one bolt up here. Don't forget that one. It's kind of hidden. It's kind of annoying. When you go to tighten these up,